Hello, hello, hello. Hi, Shikar. Hi, Mukul. How are you all doing? Good to see you all. Great, Mukul. Hi, 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 hi.
Hello everyone, good evening. I welcome you all to Pi and AI Guna meetup. Today we have a awesome topic to be covered, which is getting started with TensorFlow by Kartikey Rawat. He is a founder of developer student community and also a co-organizer at TensorFlow user group Chandigarh. At the end, we are also having a Q&A session, so don't forget to drop your question in the chat box. Hope you will enjoy it and learn something new today. Thank you.
Hey, folks. I hope so. You are doing fine in it and be safe for this right now moment. Till then, I am sharing my screen. Give me a moment, folks, and we will do some hands-on if possible. Like it depends on the time. Just let me know my screen is visible or not to all of you. Okay. Yeah, let me. Okay, I think so. It's visible. Yep.
Yes.
Let's get started with it. Earlier, like Ritesh has said, I'm a founder developer student community co-organizer at TFC Chandigarh. Recently, I am became organizer at Azure Developer Community Raipur, and I'm also a multiple co-organizer at different community. I'm a kind of a community person. If you feel any kind of, I'm a really community driven boy, you can say. So if you feel any insights about my session, take a screenshot, tag me. I will try to repost that if you given any insights, so that will be greater. And my socials are on my, you can say, in my tag here, like at the rate of carry cool dude. Those who know me know me. Doesn't waste any time. Let's get started with it. For memes, I am a meme lover. As I always said this, I am a very loved. So no argument that like there are many memes in this, so that you will got to insights of about everything about TensorFlow and machine learning. I will just introduce yourself on machine learning and how I we can introduce everything related to machine learning. Yeah. So let's get started. So first of all, I think so. Those who are a machine learning lover, they always across this kind of meme, like wondering why neural network is classifying a cat as a dog. So it's really famous meme. So now let deep dive into the traditional programming, as we concern say. So for traditional programming, we have some rules and we have some data. Suppose I'm just giving you an example, like I have to add two numbers, and what we will do, I will store a number in X and I store the second number in Y, then add it. So like in here data, we have X and Y have a data, and in the rules I have a addition. So I have a rule, I have a data, and I will get the answer. This is not, this is like a very traditional program that we do. Now what is the difference between the traditional programming and machine learning? So specifically machine learning, we having the data. That means we having, suppose if I'm doing in traditional programming 2 plus 2, that we know its answer will 4. But in the machine learning, we what we say, we have data 2 2 and answer is 4. So it can be possible that it can be 2 into 2 equal to 4 or 2 plus 2 equal to 4. It totally depends on the model that we are where that we build. But it just kind of, I'm giving you a just kind of a random example, or if for quite clear, like if I add 3 plus 3 is equal to 6, or 3 plus 3 equal to suppose karo like 3 into 3 equal to 9. So with the same thing, I am just doing the data one, like I having data 3 and 3, and it is resulting out the 9. So obviously my rule will be here multiplication, as simple as it is. So yeah, so there is a very famous like cat versus dog. You can use this, or you can use this data to you could train yourself. But I'm just giving you the fashion amnesty data set. We will do hands-on in this. So yeah, as you know, artificial intelligence, but it is totally if and else kind of thing, and that's can kind of really popular kind of, you can say, scenario right down where what we are listening from many of the memes here. So so what we have, like I'm just giving you an example here. Like I'm a person. If my speed is less than 4, or suppose that like my speed is less than 4 kilometer per hour, for taking example, that can't be possible. But yeah, for so my status will be walking. Now again, if the speed is less than 4, I am status will be walking. But it will be, if it is other than like 4, like it can be greater than 4, then my status will be running, or in negative it can be. That can be possibility. Or more, I can, if I go in the more diverse thing, like if my speed is less than 4, my status will be walking. If my speed is less than 12, then my status is running. Or if both of them is not present, that my status will be I'm doing bicycling, simple as that. So this is general, we can say, in a traditional program. But in the machine learning, what we see, like if I'm playing golf, so we have designed a perfect rules for that. Like it can be differ as like what kind of a actual speed I have to give to the ball to switch from one place to another place, or directly shot from the place A to place B. We have don't do not have a definite rule for that. So for that, we what we are doing, as again I'm just in the previous slide, as I already tell you, we have data, we have answers, we are creating the rules. So that's what the basic machine learning here is. So let's go into the really great main, like data scientist. Those who are talking about data scientist, that they are talking about many tools like sklearn, pytorch. So they are always mixing with some pymatplotlib, pandas kind of library into data. So that what data scientists do. And so me, after training a neural network, and I'm just talking a bit about neural network here because it's kind of a localization in the TensorFlow, kind of more on this. But yeah, when you code up the model the first time, yeah, like I created my first neural network. It's kind of a really cool. Yeah, but in reality, when you become a like it's kind of Avenger meme, when you did become an expert in deep learning. So yeah, I didn't. I didn't nothing, because it's all thing is done by the TensorFlow only. So TensorFlow has an abstraction part of many libraries, or you can say neural networks. So what is TensorFlow actually? So TensorFlow is an open source library for machine learning in which you can do scientific calculation, computation, and many more. So now what I'm just giving you the here the how TensorFlow came into the, you can say, pocket of Google. So first of all, the whole TensorFlow is just an abstraction of, you can say, the Keras. If you go in the keras.io website, you will see many things updated now till, but most of the part is taken by the Google and under the TensorFlow team, you can say. So first version is released at June 2015, and version 1.0 basically released on April 2016. So on January 2017, Google has taken that and Keras frontend to include in the TensorFlow core that we are seeing here. And so it can be different to version. Like I'm just comparing because it's kind of open source project. So everyone here, I just collaborating with each other and doing something stuff like that. So same with that. If May 2017 version 2.0, so Microsoft and Amazon also collaborated with TensorFlow to bring out something new in the deep neural network. We didn't go into the diverse end here, but let's go into the main thing. So what are the you can say, the tools or libraries that we use in machine learning prioritizely? But I will focus on the here in TensorFlow, or you can say specifically on the Keras point of view. What is that? So TensorFlow. Let's do this. And so basic, I'm just going into the, you can say, everything about what is how to install that kind of thing. Okay. So this simple installation, like if you are in the if you have a version, you can say, environment of Conda, that you can directly install Conda, install TensorFlow. And you can see in the website of TensorFlow that will be proper, because in every time there will be updation in, but it same simple is that as this is. Okay, let me give a dot, that will be better. Yep. So Yep. Same with if you have a pip, that will be better, like pip install TensorFlow, or if your GPU like NVIDIA has a supporting in your system, that will be also better for you. So yep. So now the main basic agenda, what is ARs and how you are introduced in the TensorFlow kind of thing. So yep, I'm floating through the code base. Don't be afraid, folks. We are doing the hands-on right now, so you will get everything about what I'm doing, how I'm everything doing is. But for a simple scenario, what I'm doing is I'm just creating two variable x in TensorFlow. How we create a variable by this tf dot placeholder. Same with y. I'm creating two variable x and y here. Now I'm just using some layers of the deep neural network, so that can be like kind of a bouncer for you. Many of you don't take stress on it. We didn't work on that because it's kind of a very back on kind of thing. But most on that models, what I'm doing here, I'm taking an image and convert into as small as, so that I get a shape. Like if like suppose I have one image 2 to 3 MB, and I have a multiple image about 10,000, that will be the great, like a data will be great, and the training on that data will be difficult because it takes too much time. So for that, what we are doing, we are reducing the size by doing flattening this kind of a layer. You will introduce when we are doing something convolutional neural network. You can study that. I will share the resources of that too, so don't take tension on that. So what I'm doing, I'm adding the layers one by one in order to understand the whole data semantics basically. Now what do I mean about data semantics here? Data semantics basically here means I am just taking the note of what actually data is. If suppose it is text, so I will you can say in the NLP end, I can see I will approach to one word. Like if I write my name is Kartikey Rawat, so my my, I'm taking one characterization for that. That is basically called tokenization. So I'm just learning how what that actually means, and I want to understand that thing to the machine. So that was the basic concept of machine learning here right now, or you can see in the deep neural network, that you can say, but don't focus on that. I'm giving you somewhat about basics of TensorFlow frameworks basically. So there are two frameworks: TensorFlow Lite, that is totally basic on the, you can say, the mobile devices. If you want to approach that into more devices, like smaller devices, not in the big end productions, so that we use in TensorFlow Lite. And TensorFlow.js, that is one of my favorite because I am a contributor to TensorFlow.js, and it is totally based on how a JavaScript engineer can start machine learning using TensorFlow.js. You didn't need to understand whole architecture of machine learning, but if you know the basics of machine learning, you can implement TensorFlow.js in a very easy thing. Okay, so yep. So that's what the agenda. As you know, in the right hand side, you can see that I'm drawing three, and it is just predicting. So that's totally a TensorFlow.js. You need nothing. I will also share the somewhat about the main agenda of how you can contribute in sense of if it is possible to be a contributor at non-code based area. So that will be also easy for you. So don't take tension on that. Okay. So yep. Now I'm just going you MNS data set, and we will working on a fashion MNS data set. So don't worry what I'm doing here. Let me know. So what is basically an MNS data set? So MNS data set is that kind of set in which we have a number 0 to 9, and it is the images that is present in very micro images and in a different form. Like in 0, it can be of different form, like 0 like this, and this. There is many structure of it. You can search in on the Google by writing MNS dataset or MNS. You will get to know about the whole structure of it. So that just understand it's the value of 0 to 9 that we are working on it. I'm just giving you an example here. We will do hands-on on the fashion MNS dataset that will be more higher than it, but you can understand very easily. So don't take tension on that. Okay. So what we are doing here, I am doing here specifically, I am just converting the data set into two train and test, as you see here. So why I'm dividing into train and test data set, and what is basically train and test data set? So train data set are suppose there is 100% data set. I'm just assuming the data set I'm having, I'm taking is 100%, and taken the part of it about into converting into 70 to 80% into train data set, because we have to train that. I have to create a model so that in which through that data run on that model, or it can be classifier of, you can say, 0 to 9, in which number we have to decide on that. So that's big agenda. And rest one 10% or 20% rest one are those in which we have to test that my model is correct on. So that's what the basic agenda here. Okay, so like I divided the MLS data set into X train, Y train, and X test, Y test. Simple. It is a basic it is a basic kind of, you can say, understanding of it, because in TensorFlow, if we want, if you're working in Python, there is a function called split test data set, split train test data set, that kind of thing. But in TensorFlow, there is a function called dot load data. You have to just load that data, and splitting is really easy. Just kind of a use of the splitter. There is a Python function here. So yep. Now what I'm doing here, why I'm dividing that X train and X test into 255.0? So because it's a kind of image, so it can be, its value will be refer from 0 to 255. So that can be a very wide range of value. So what I'm doing here, I'm just dividing that into 255 so that it can convert into the range of the 0 to 1. So that will be easy for us to train that model in a very faster way. So that's basically agenda what we why we are dividing 20. And why I'm using zero point 0, because it can be possible, but nothing like that it always a whole number. It can be a floating point also. So that's why I'm dividing by 255.0, because it's kind of a basic concept of programming. If we are dividing by 255, then it only give integer, not the float. So all the float value will remain that part. So for include the floating point value here, that what we are using here. Okay. So what actually, like if I'm just focusing on model is equal to tf dot keras dot model dot sequential, I'm just adding the, as I know, the layers part of it. So what I'm doing here, tf dot keras dot layer dot flatten here, as I already said in the previous slide, that why I'm doing here word flatten, I have to reduce the size of the image. That's why I'm able to speed up the modeling part of the machine learning. And same with dance dropout. If you are just working on the convolutional neural network, you will get everything because it's totally working on image. So just understand what I'm doing here. For more, like if we go in depth of everything, so that is the activation that you are seeing here, that is totally focused on the neural network. There's a tf dot, tf means TensorFlow, nn means neural network, and relu means is there's a kind of a activation function. You can search on the Google also the relu activation function, and you will get this kind of this kind of, like it's coming from that, and always positive basically. When it goes from the graph of the negative, it automatically convert to 0. That's basic agenda of relu function. So that we are using here. And same with the softmax function. Now I have to compile whole thing. So what I'm doing, I am using an optimizer called Adam. It a really you can say many of the machine learning engineers know this Adam optimizer. So yep. And loss function. So what basically loss function is, like in loss function, the specific agenda is here is just to understand if there is any data leaking here. Leaking in sense, it can be possible that, suppose I have a many data, but it also required for a machine learning engineer to understand that, to transfer the whole data, like it can be like 2 GB, 3 GB, or it can be 500 GB. Suppose leaking of data is really necessary. If the data is leaking, that will be your model will be poor. Your model have to be, you can say, under overfitting. That's not the case, or that's not the topic of this session, but just to understand the loss function, really important. If we reduce the loss function, it will be a better for you to give your predictability, or you can say prediction of that model will be greater, will be higher. And the metric that I'm using, as always, accuracy. After that, after I compile whole model here, I want to fit that. Fit means I just want to test that data with my test data. Simple as this. So what I'm doing, model.fit extend whiten, and epoch is just with kind of iteration, what kind number of iteration I'm doing that model. Like one model, like suppose if here is written epoch equal to 5. So what I'm doing here, iteration will be done 5 times, like it will be run 5 times regularly, so that the model will be evaluated pretty much higher. Just to understand, if you increase the epoch, it can be chances that your model accuracy can be improved, but it just kind of a totally matter on the supervised learning, not if you're working on unsupervised learning, suppose. So that can be a kind of a bit kind of session that can be not possible by increasing the epoch. That means, yeah, you have to add more layers to that. At the end, if you want to evaluate that thing, how much accuracy it will predict. So model dot evaluate x test and y test, that we store in the starting, that is here, x test, y test, and converting this x test into 255. Simple as that. So thank you for everyone for your patience. So yeah, now the time is on the hands on. Let me know, is there any? I don't think so. There is no one. Okay, let me share again. Yep. Give me a moment, folks. Yep. That will be better. Let me know my screen is visible or not. Yep. So we will do hands-on here, and at the end we will discuss all the your questions Q&A at the end, so that it will be better for me also and you also to discuss on that. Yep. So let's get started, folks. So now I'm just here using, you can say, more on the, you can say, fashion MNS dataset. For that, you can search on the dataset, but I will show you everything here. So first of all, let's import the TensorFlow. And for also, if it is totally depend if it also like Keras is under TensorFlow, but if you want to import TensorFlow Keras, that will be also better. So yep, import Keras. Let's run this. So I'm first of all I have to import the libraries. Let's see, importing the libraries. Till then, is my screen okay? I think so. Yeah, let me check. Let me check. Yeah, it gives me some more time because it is, as you see in the right top corner, connecting. Till then, we can import also matplotlib. Matplot. Just enter control plus space. It will show you the main you can say the libraries that you are using here. So sorry, first of all, let import numpy as np. Yep. And for more sorry, also, like, it will be better for me to introduce as tf. That will be easy for you. And import and then import matplot. For more conservative, I can use matplotlib dot pyplot. Yeah, as you know, it's already there because it's kind of a general kind of thing, many people are used here. So let's run this. So now let's check, like, my library is imported or not. For that, let's print this. So print tf dot version. Let's check the, like, it's tf is working or not. Let's check. So yeah, it's working, I think so. Yep, 2.4.1. It's the current version that we are using. Now I have to import the fashion MNet dataset. Now it is really good in TensorFlow. Like, we are having some basic dataset is present in the TensorFlow, only TensorFlow dataset. If you go to the TensorFlow or you can say GitHub, or you will see there is a dataset kind of a repo is there in that organization. So you can, if you want, you can also contribute in the dataset too if you want to. So till then, let me start with the variable like fashion amnest. Like, sorry, fashion amnest. So what, like, I created the variable. Now what I have to do here, so let keras dot data set. Okay, now what I have to import here, so sorry, data sets, it will be dot fashion amnest. Yep. And let me bring this as a amnest. Yep. Let run this first of all to store the basically the whole data set here. Now what I have to do here, now I have to distribute, or you can just split the data into the train images and train labels. That what the agenda is. So what I am doing here, let's create one. So one is for, first of all, what I have to focus on now in this training. So there will be training images and training train labels specifically. Okay, same with the, you can see the test one, test images, comma, test labels, and equal to, now I have to split, or you can say load that data, as I already said in earlier. So what I'm doing here, I'm just using this variable because I stored this whole fashion MNS data, fashion MNS variable. So what I'm doing here, fashion MNS dot load. Now, as earlier I said, it will be load data. Okay, so let's run this. Let's see. it will be. Okay, so as you know, I downloaded a whole data here. Okay, so okay, so okay, now we have downloaded the whole thing. Now I have to create it. We want to create the class name here to understand what the class name are. So for you guys, I already declared some of the class names. So for that, I'm just copying whole thing so that it will be easy for you. You can check that I made this earlier so that you can, it will be better for our time saving kind of thing. And initialize this list class names. This I initializes the list. Now what we have to do here, now I have to print, so that I need to understand the what are the dimensions of it, what are the number of training labels of it. So for that, what we are doing here, let just write print. Now what we are supposed to do, first of all, we have to understand what are the dimension of training data set. Yeah, so for that, just use sorry, train images dot shape. Image, the first image of it. So what I'm, as already know, give me okay, till then, yep. So yeah, till then, now I have to, let's see the first image of it. So what, as I if as you already know, I just imported the matplotlib that will be easy because I will show you in the terms of in the plotting form, so that you will understand better. So as you know, we use here PLT. So like as a so PLT dot, what we have to do here, we have to use a function called figure. Okay. After that, it will be one to show the figure. Now I have to show the image for that. So PLT dot I am show. Now in I am show, what parameters I have to pass, that basically nothing parameter, that is the train images, and that will be the one, sorry, zero, because the first image will be zero. It's kind of array or list that if you pass on in the Python library, Python, basically Python. And now I'm just colorizing that part into like PLT dot color. You can say color bar, maybe, I think so it will be color bar. And yep, color bar. And after that, what I have to pass in color bar? Nothing, because it's automatically take up the whole color. And after that, PLT dot. Now at the end, just I'm just want to grid will be, I just didn't want to include the grid, so that's why I've just passed this as a false. So let's run this. Let's see what we get. Gotcha. Yeah, so this is our first images. And if you want to change it, like about the second image, just update this. Or if you want, you can create a loop for that, so from 0 to I, and all the image will be showed here. I will do that in the later, but now, like, it is a second image. So for first of all, focus on the first image of it, in the basically the in the fashion amnesty data set. So now, so why, like I already said you, like, why I'm dividing it to 255. So like, we see that pixel value range, normal pixel value ranges from 0 to 255. Also, you can check it here, it is go to about 250, but it is just about somewhat higher, that is really about 255, the pixel value. Now we will scale this range of 0 to 1 before feeding into neural network model. Why I'm doing this? Because I didn't want that whole model, because this is kind of an image of love about you can say 3 MB, but I'm taking, if you see earlier, our total model is about 60,000. It will be huge. So if you want to reduce, what I'm doing here, let me show you, then I will show you a whole part of it. Like, let's yep, let's divide the whole train and basically train images and test images. So what I'm doing, a train, sorry, again, train images, yep, dividing that with 255.0. Why I'm using point 0? In order to make it into floating point, because here you can see there are some pixel between the decimal point also. So how we can use that? So that's why I have to use point 0. And same with test images, about 255.0. And let's run this first of all. Okay, now, scene is that I have to display it. Why I'm doing this, I will let you know. Till then, let's copy and paste this whole thing. And let sorry, I have you, like, if you run this, is always show the color. But if you want to show in the MNES dataset specifically, so what I'm doing here, let's create a PLT dot figure as always. Now what I'm doing here, I am just giving you some parameter as figure size, that is converted into the 10, because I will let you know why I'm using here. So I am using here a figure size of about, you can say, 10 maybe. Yep, 10 cross 10 will be better. 10 comma 10. Okay, now what I'm doing here, I'm creating a loop for the range of, you can say, from, you can say, 0 to 9, 0 to 10, that can be a case. So let's create a loop for I in range of 10. And if I am inputting 10, then it will range from 0 to 9, that is almost a 10 you can say images only. And yep, this is kind of a basic Python for looping kind of thing. So what I'm doing here, I'm just using the subplot here. Why I'm using subplot, that's not a big agenda here, because I want to use this whole area in terms of dividing that into the, you can say, the 10 parts, basically subplotting. So what I'm doing here, I'm just passing initially 5 comma 5 plus I, because I have to update that. Yep, as simple as it is. Or also, like, one thing I forgot, I have to, there is two parameter. If you want to understand whole thing, let me give me a moment. Yep. So yep, now I created my subplots here. Now I have to give some, you can say, the text, you can say, just want, I'm doing the specifically the CSS part, you can say CSS. I'm just doing here CSS plt.ytix. Okay. Now what I'm doing here right now, I'm just adding the as same as grid, because in general grid will be true. So I'm just removing the grid, so by passing false parameter, plt.create false. And now I have to show that thing. Okay, so plt dot I am show. These are the some function that you will use if you will got into that. But yeah, after that, sorry, train images in bracket I, because I am just using the loop of hold it, and passing a parameter of cmap. So in cmap, what I'm using here, like, there is a function called plt.cm.binary. Okay, that will be better. Now I'm just at the end, I'm just using I'm doing a labeling, like plt dot, specifically, if I'm just focusing, yeah, let's label that about x label. There's a function called x label, in which on the x-axis you will label of all of it. And what I'm labeling, as I already initialized class names here, I think so here, yep, class name. So that's why it will be easier for us to understand from which image or from which class it is belong. And just I have to do nothing, I just to pass a train labels of it, and passing parameter I. Let's run this. So yeah, have you see this image just converted into black and white? That means it converted into 0 to 1 range. If you see in a proper manner, it is in the color right now. The division of 255 here, this one is actually what the range between 0 to 255 just converted into 0 to 1, that is in the grayscale. And grayscale is less has a less space as if there's two class, then we will use binary, otherwise we will using cross entropy one. So how like right is sparse categorical cross entropy.
Hello, hello,
Okay,
hello,
that will be
Kartikey.
better. Now,
Hello, hello, hello.
yeah,
Yeah, sorry to disturb you,
yeah,
sir.
yeah, yeah.
Yeah, yeah. So you are disconnected from, I think, from model. So please carry on from there. I think you are disconnected from there. Some
Okay,
network issue from your side.
sorry, folks.
Yeah, yeah, yeah.
Like here,
So
yeah.
yeah, yeah, yeah.
So this one, you are asking for this one, no?
Yeah,
Model.
yes, sir. Yeah, from
Okay,
this
yeah.
side.
Thank
Yeah,
you, thank you for the let me. Yeah.
yeah, sure.
So yeah. So like folks, what we are doing here, like I'm just creating a sequential series of you can say the layers. As I already know, you didn't have to understand whole thing what we are doing because it's a part of a neural network. But it just want to it will give you a brief insight of it. So what we are doing here, I'm just adding one layer of flatten in order to reduce the image as possible because it is easy for us to because the time if I like I feel if I didn't use this, so what will happen here, the whole model will take so much time because the image quality is really high. So yeah, like I am not having a TP or you can say Google server to run whole machine learning model in a very big servers, but we are using on the collab that is in the cloud computing, and it requires so much power and so much time to it. That's why the concept of supercomputers and quantum computers came into play. So in order to increase the speed of model running, machine learning model running on the system on the servers. So yep, that's why I'm using the flatten here in order to reduce that. Same with the dense layer. Dense layer just passing the activation function. This activation function, if you want, I can share you on that and at the end. So what basically the ReLU function, the tf.nn.relu. TF means TensorFlow, NN means neural network, and ReLU means basically the ReLU optimizer, or you can say activation function. Same with the softmax. At the end, I will share you what basically ReLU and softmax function is. So yeah, I think so. That's where this will be just a kind of introduction of everyone. And let me start with model one. Okay, as you know, what I'm doing here, I'm just adding a optimizer. So for start, I can repeat that again. So what is basically you can say the optimizer and loss function kind of thing. So first of all, what is loss function? Loss function is this measure how accurate the model is during the training. We still not started the training, but how accurate the model is during the training, and we want to minimize it in order to make our model so steer, you can say, in terms of when we're going for the graph thing and we're taking slope. The better it's steer, the better will the function is. And what the optimizer is, it is how the model is updated based on the data it sees and its loss function specifically. And metrics, as always everyone sees, it's kind of accuracy kind of thing. So yeah, so now yeah, now I have to add the metric here. Metric will be our accuracy. Let's first of all run this. Let's see, there's no error coming here. Let's see. Okay, I hope so. Yeah, it's no up now. The main thing has came. Now I have to check the is model. I have to now I have to train the model. For that, the function we are using here, fit function. So model dot fit. Now in what are the parameters going in this one? First of all, I have to pass training images, training labels, and then at last the epoch, as I already said. So train images, then train labels, and at the last epoch specifically equal to 5. Okay, so right here like now we have to, sorry, it will be epochs, I think so. Yep, let's run this first of all. Let's see. Now we are training our model. Yep, it's training. So you will see the loss function how it's reducing the accuracy one. Let's see, it will be on the running mode. Let's see till then. Yep. Yep. So as you know, you will see the loss function in the first one. Loss, the keyword loss is written. The loss function is reducing. That's why our model is doing great, good as compared to us, because our accuracy is also increasing from one epoch to another epoch. It will be better. It will give more precise manner if like I am just converting this into 15. Let's see. Let's run this again so that you will get some insights about it. like how by increasing and lowering the epoch, how the it's epoch totally dependent on the, you can say, accuracy. Let's see this. Let's train this. Let's see this. And also, if your you can say whole function is coming from, in if above than 90%, that is it's good. And if it's greater than 95%, then I will say your model is really really good, because neither a model can came into 100%, that can't be possible, according to the hypothesis of machine learning, and you can say. And it is in the end one. Let's see. Yep. So 93%, it's great. It's like our model is doing great. And if I add more layers, so your activation function also reduce, also increase. Let's check it. Let's again copy this whole thing. Let's see it will increase or not. Let's see this. I will doing copy and paste, and yep, as usual. Let's run this model. Okay. Let's this. Now I'm just reducing that back to the, you can say, about, you can say, 8. That will be better. And let's fit this model again. I am doing this again. That's why you get an idea of what actually we are doing here. So let's see. By adding one layer, it can create any impact in accuracy. Let's see. So yeah, as you see, accuracy reduced. So that's what the agenda is. That's what I'm just focusing, try to don't able to do. That's if it can also be possibility, if I'm adding more and more layer, it can be possibility improve, but that can be totally depend on your activation function that you are using. For now, if it is greater than 90%, it is good. It is good. Now what I'm doing here right now I am just dividing this. I have now test the accuracy, what actually the whole test accuracy is going through. So what I'm doing here, I'm creating a variable test loss, and one more parameter that will be a test accuracy. So for test accuracy, let's bring this as a test ACC, and just passing a parameter here. Now what we're passing, now we are using a evaluate function to evaluate the accuracy focus. So what we're doing, model dot uh, evaluate. Yep. And now in the evaluate function, what we have to pass as usual. Now we have to test this. So test images, comma, sorry, test labels. Let's run this. Okay. After running, yep. Yeah. Now let's see what is the accuracy. Let's print the test ACC. Let's see what is the basically what will we show basically. So 0.88, it's about 90%, about 90%, you can say it's good. Yep. So our function is like neither good, neither bad. It is about 90%, is okay. Okay. Now I have to make prediction of it. So what we can do here, let's create a variable kind of prediction, suppose, or prediction, and just passing a parameter like mod predict. There is a function called mod predict, is the, you can say, the function specifically. And now pass the parameter test images, because I have to test it. Let's run this. And after that, after it's happening, let's, sorry, oh sorry, what I'm doing here. Yep. Now prediction, I'm passing the parameter as a 0. Okay, because the first element that we are totally focused on, like I can say here as predicting first element. Yep, that will be better. Now let's search it. Let's search it. Let's see what it will show to us. So yep, it will show you about a greater prediction. Like it depends on total value. So since we use sort function, sort max for our last level, so we can get an array of 10 probability ending up to one. That's basically the index that we are showing here. It is basically the probability, highest probability, and the probability is really good if you see. And like if you want more, like if you want the basically, like if I use the numpy here, now you will so use the what is the numpy. This is a function called argument max. Basically it totally depends on the argumentation basically. So what I'm doing here, again I'm just using the prediction, prediction, and pass as a 0, and let's run this. Okay, running, let's see. Yeah, so it's came yeah, so after this it's came 9. That is our first element, you will see, and it's totally correct. Our prediction is getting correct. If you will see at the starting, I will show you like a training level of first one. So it is showing absolutely correct. It's true. If you see, it's true. It's totally fine. It is doing great, and we are actually doing great for a thing. Same way, if you want to do it test with labels, you can also do that, but it totally depends. So yep, this is the end of this, and if you want, I can share the whole thing, whole collab link with you all. Yeah, and let's bring some question if you having any questions. Yeah, Ritesh, are you there?
Yes, Kartikey. It's been an
Yeah.
awesome session. Yeah, seeing you today doing a hands-on over building a end-to-end neural network. It's great. Showing each and everything from model training to building. Yeah, it's awesome. So, everyone who has ever any question, doubt, you can ask in the chat box. Yeah. So let me put up question.
So like okay, like I already answered that, but I can again answer that. Like why we divided by 255? Like the range RGB value ranges from about 0 to 55 in that specifically that you can say the ranges of the basically RGB values. So for if you want to speed up the training, we have to reduce the data in terms of quality. So I reduces it. I convert that into by dividing 255. I just converting into 0 to 1, so it will just reduce into, you will see it, I just converted that into the gray scale that is in the black and white color after doing that. So yeah, so that's a basic concept that why we are doing here to improve the, you can say, accuracy in order to use less quality data. Because like if I run like that without that, that will be ranges from different values, because training that data is really much harder for us. So for what we did, we divided by 255, and yes, I hope so you clear that. And yeah.
So any more question? Anyone?
And if you want, you can connect. Yeah.
Anyone having any other question? Karthik is happy to answer you all. So anyone having any
Also,
question? Yes. Karthik, you are saying
yeah.
something.
Yeah, no, I'm saying just like if you want to connect with me, you can follow me on that. Like just kind of thing. If you want to connect, if you want to share anything, like I mostly active on Twitter, like I will less active in LinkedIn, supposedly I can say. But yeah, okay, there's one more question. What happening on increasing the number of hidden layer in the background? So yeah, that's what the concept. Like I'm telling, it totally depends on the activation function that we are working. You can search on different activation function that is used in our deep neural network or machine learning specifically. But if we increase the number of hidden layers, it will retrain. It will retain maximum time. Like suppose I added number of layers into, you can say, number of neurons. Suppose 128, and I just copied same layer with multiple times, so it will retain multiple times. So what is the reason that I will want to get higher result, like higher accuracy, but I get smaller. Like in the previous one, you will see my accuracy about 93%, but it's dropped down to 90%. The reason is because I didn't select the good optimizers, or you can say the good let me check, give me a moment for that. I use here, let me give me a moment, folks. Yeah, so the activation function. So the checking of activation function really really important. Which activation function used where in which layer, it's really important. In terms of when we are focusing on the convolutional neural network, it is really important which layer you are using, and in that layer which activation function you are using. So that's why my reduce it. But if I using, like, suppose if I use software expansion, it cannot hit and trial kind of function. But it totally depends on the, you can say, if you're working on the research end or the machine learning, you will get everything. So yeah, that's what the con.
So, anyone having any more question, you can drop here in the chat.
Yep, it totally, yeah. As I already said, there is a can be a possibility of underfitting or overfitting the data. If you use many times of layer, it can be result of less than 50% also accuracy. So just see the what case you are working on. Like if you are interning in any machine, specifically machine learning intern, and you have given a you can say a task on the specifically on the images kind of thing. But if it can.
Oh, I think speaker has been disconnected. So yeah, we can wait for 5 minutes. He will be connected soon. So wait.
Like is a
Hello.
stream over for? So
No,
there's
no,
the
no, no.
network issue
Yeah,
on. Hello, like,
yeah,
sorry for sorry, there's a network issue on my end. That's why. Sorry.
yeah, yeah. It's okay. Yeah, good to go.
So yeah, is it live or like it's ended?
Yeah, you. We have not ended. It's live. Yeah, it's live. Currently, it is live.
Okay, yeah. So yep, I hope so. Like there's a total case on that. Like you have to check the case base or the base area of it. So it's nothing else, and just it's on that point only. Like what is the base case you are working on, and on it's kind of a, you can say, because machine learning is total research based, so you can't say like if I increase that anything. So yeah, that's what the agenda is here. And
So,
if we this session kind of very some full insightful, so you can take a screenshot, tag Ritesh and me on the socials, and yeah.
it's a great session. It's a great session. Doing a hands-on over it, explaining everything from end to end. It's great. Thing, yeah. So, folks, if you have any question, you can connect with Kartikey on Twitter, LinkedIn, any platform you want. He's active on every platform, mostly on Twitter. So you can get in touch with him and ask any question about related to the session and the anything you want to get to know about TensorFlow JS or how to deploy in light devices. He's ready to help you on. So so that's it. So we have an awesome session
Yep.
today, Karthike. So let us and if you have any question, you can drop here. So you can connect with the Karthike and get a can do a one-to-one
Yep,
chat.
sure.
He
If you
will be
want,
very happy.
like it will be better. I and Ritesh already met in LinkedIn, so LinkedIn will be better. But like I will say, reach out to me in Twitter, because in Twitter I'm really really on Twitter, in Twitter Spaces, and yeah, that will be better to be connect me on Twitter, or like both can be possible. Twitter and LinkedIn, I will be on both.
Yeah, yeah, yeah. Sure. So it's great to have you here today. So let's thank you, thank you joining us, folks, joining us today, and it's been a great session. So till then, bye bye everyone. So bye everyone. Thanks Param.
Hi
Thanks
Ritesh.
Param. Thanks Param. Yeah. So bye everyone.
Thanks.
My hand is not coming. Yeah. So bye.